My name is Iffat Afsara Prome, and this is our CSC 461 project video, and we are group 19 and my teammate's name is Raihan Rahman. My project, here we can see that the robot is on the track and the environment is in the rectangular arena. So it's a pre-built rectangular arena with its 4 walls, and yes, the track. And for the body of the robot we have used some basic mechanism, and for the colors we use the basic colors. So moving on to the body of the robot, we have choose a basic cylindrical shape for our robot, and of course we can adjust the scale of our robot by making it smaller or bigger, however we want. And then of course we applied the bounding objects so that our robot can be collidable, and physics so that it can properly work on the environment. Okay, so in the children part you can see that we have our components here, 2 hinge joint for its 2 wheels. So of course we followed the rules that the anchor value of the hinge joint will be the same as the end point of the translation value, so that our wheel can work properly. And we used hinge joint, of course, so that our wheels can properly be attached with the body. All right, so of course in both of our wheels we also added the bounding object and physics. And yeah, that's all for our robot part. Next, my teammate will be presenting about the code and the mechanism and the track of this project. Thank you so much.
Assalamu alaikum, and thank you very much, Prome, for your presentation. So my name is Raihan Rahman and my ID is 1810169, and I'm the second member of our group 19. So this part I will discuss about the code implementation for this final project and how the line following robots actually follow the systems, and what happens if we implement PIDs and what will not happen if we don't input the PIDs. For 2-wheelers, it is pretty easy for us to implement the non-PID Python controller, because we only have 2 conditions here to balance the wheels, wheel 1 and 2. We don't exactly have to do any preconditioning for our wheels speed in terms. So first we will discuss about how we can ignore the PID sections to run the robot simulations. So we have already have taken the import of the robotics body. We have taken the cameras at the import from the controller, and if we go to the robotics part, we have taken a time step of 64, and our max speed has been pre-modified as 4. So we have described wheel 1 as the left wheel and right wheel as the wheel 2 that we have implemented into the child part of our sensors. And we have set the positions in both wheel 1 and 2 into the infinity, and we have set values to 0 at the first. So we have a left sensors and right sensors. So these sensors that we have implemented here, it will help us to track the line and let the robot follow the line the way we wanted it to be. And we have enabled the sensors in this 2 part here, and we also have enabled the camera and send the camera details to our to the camera view in here. So the next part is about the managing the wheels of the robots. As we can see, we have taken values from the left and the right IR sensors, and then we have to compromise the left or the right wheel speed, so that when we take turns into left or right, the robots do not get hesitated or hefty along the path, so that it do not go off the track. And that's why we don't need to implement a PID in case of the wheeling. So if we run the simulation here, we can see that the robot is following as we want it to be. So what happens if we use the PID? PID is actually a conditioning that can help us to determine if we go up balance, if we have multiple wheels. Like for 4-wheelers, it is pretty predominated that we have to use the PIDs. For the PIDs, we will see if our program gets an error. So we will describe an if-else and if-else situations. When the wheels goes off track, we will send a PID error. We'll send a PID error measurements, and we will get the measurement, and we use the measurements to give our wheels a perfect balance. That's why we use the PIDs for. This is a PID calculation or balancing part where we will measure the errors if we have a four-wheelers. So thank you very much.